Hello, good morning, everyone, and a very warm welcome to the RIBA Gulf and Geberit seminar series. Thank you, everyone, for joining us this morning for the second module of the seminar series. I hope you and your families are safe and doing well at this unpredictable time. I am Mithuna Murugesh, the Business Development Manager for the Gulf. As many of you might know, the RIBA have recently opened one of its first international offices in Sharjah in the UAE. I'm delighted to announce that the RIBA have chosen the GCC as one of its key international locations to further serve our global architects. Due to the unprecedented situation we are all facing with the current pandemic, the RIBA has decided to open the RIBA Gulf and Geberit seminar series to 7 countries across the Gulf. And today we have members tuning in once again from the United Arab Emirates, Kuwait, Bahrain, Qatar, the Kingdom of Saudi Arabia, the Sultanate of Oman, as well as Jordan. Today's module of the RIBA Gulf and Geberit seminar series will provide an insight on siphonic rainwater systems. Please do send across any questions regarding today's presentation in the chat bar alongside at any point of time, and our speaker today will attend to them in the last 15 minutes Q&A session. Lastly, I would like to thank Geberit for their kind support in sponsoring the seminar series. At this point of time, I would like to introduce Louise Pitt, the Marketing and CRM Manager for Geberit International Sales, to introduce us to our speaker today.
So good morning, everybody. Thank you, Mituna, for the warm welcome there and the introduction. My name is Louise and I handle the marketing for Geberit in the Gulf Regional Office. And on behalf of Geberit, I would like to welcome all the delegates today to our seminar. I would also like to introduce to you our speaker, Mr. Remo Hirschi. Remo is a Swiss national and he's 38 years old. He started his professional career back in 1996 as an apprenticeship in plumbing technology. He completed his Bachelor of Science in HVAC engineering and he joined us at Geberit 6 years ago. For Geberit, he's travelled extensively around the MENA region and we were lucky enough to have him join us in the Gulf Regional Office about a year ago now. And Remo heads up product management and technical support for the region. So on that note, I'd like to ask Remo to introduce himself again and start with our seminar today. Thank you.
Good morning, everybody. Also from my side, my name is Remo. Thank you for the introduction. And again, thanks for the opportunity to present here to you. It's the second webinar we're having. A few weeks ago, we were talking about drainage in high-rise buildings or drainage without compromise. So today's topics will be about siphonic roof drainage. I'm just quickly going to share my presentation. This will take a few seconds. So I think we are all set and the presentation should be on your screens. So as mentioned, as you know, today is about siphonic rainwater systems. So the objective of today's session is basically to differentiate between a gravity and a siphonic rainwater drainage system and to understand the principles of a siphonic system and in relation to the design criteria and yeah, basically to understand what is the difference between siphonic and conventional drainage. Therefore, we have an agenda prepared. As last time, there will be a quick introduction about us, the company Geberit, who we are. And then we're heading straight into the topic, which then basically is, first of all, how is siphonic drainage different to conventional? And how does a siphonic rainwater drainage work? What are the different elements of the system? We will have a look into this. And then last but not least, also we want to briefly understand how to easily design a siphonic rainwater system. So let's start with the introduction to Geberit. Just a few days ago, our company released a new company movie And this explains very well the company of Geberit, and also for the people who joined already the first webinar. It will be a little bit a different introduction. I will not going to repeat what I did in the first time. Let's have a look.
Wie geht das genau?
And what about the pipes?
Huh? Und was ist mit Schulung? Und was ist mit... Und was ist mit... Und was ist mit... Fertig. Fertig.
Yeah, so that was very well, very nice introduction to our company. We are a Swiss-based company, a European market leader in sanitary products. We have a global presence. We are in about 50 countries over the world. We have 29 production sites, which are most of them very close to our key markets. Geberit is listed in the Swiss market stock market, and since 2012 included in Swiss market index. We have 3 brands, Geberit, Colo, and Twyford, and our business model is the push-pull principle. Some key facts of last year: our turnover is around 3.1 billion Swiss francs. You have seen from the video we are nowadays about 12,000 employees, and I mentioned the sites and the countries where we are, the number of countries where we are active. To have a quick glimpse on the total products, we have 3 product areas, which are installation and flushing systems, and you can see the share of the annual turnover. Then today we're going to talk about piping systems, which you can see here. So here we have basically in-house drainage and siphonic roof drainage. And last but not least, bathroom systems, everything which is in front of wall. So this sums up to 9 product lines in total. Now let's come to the topic of siphonic roof drainage. How does it differ to conventional? So here what we see is always on the top of the slides, the conventional roof drainage system, and below a siphonic roof drainage system. I might use the term pluvia quite often during the presentation. That's just the fact that in Geberit, our siphonic roof drainage system is called Geberit pluvia. But let's look at this comparison from a neutral point of view. So we have, first of all, a scenario where there is partial filling of the system. This means when the rainfall intensity is less than what has been designed, in both of the systems there is a partial filling of water and air inside the pipes. For the ones who joined the first series of this webinars, they might remember also from in-house training, we were talking quite a lot about that filling ratio. So basically here we have the same scenario. But when we compare a rainfall during a rainfall where the intensity of the rain in liters per second, or let's say in volume over time, is as per the design, then there will be a difference between the two systems. So the filling ratio mainly is the difference. So there we have still a ratio of air and water in the conventional system, where we want to achieve in the siphonic system a full filling of the siphonic system, or of the pipe work. And here the siphonic system works with negative pressure as a result of the full filling. So the pipe diameter is a major difference. As an example, a siphonic system approximately comes with the half diameter of a conventional system, only because of the fact that we don't need the air ratio within the pipe system. Nicely shown here on that illustration. It's clear if we have only water in the pipe, we can reduce the diameter to drain away the same amount of water. Furthermore, above again a conventional system, below a siphonic system, if we look on already the capacity per outlet, we see that the nature of conventional outlet is that they have a lesser capacity to what a siphonic outlet can discharge in the same time. So we can see here usually a conventional outlet can discharge between 4.5 to, let's say, 6 liters. That definitely depends on the diameter of or the size of the outlet. But let's say roughly here we are between 4.5 to 6 liters, where siphonic outlets can drain much more in the same time. So means we need lesser outlets for the same amount of waters. Then as well, if we look into the conceptual layout as well, usually a consultant tries to divert a rainwater downpipe as straight as possible from the roof to the underground network. And in the siphonic, the system is based on horizontal collectors below the roofs. So this means we can reduce stacks, downpipes, or insulation ducts which are needed. And as well, if we think then, as a result of that layout, if we think on the foundation slab, then definitely there is an opportunity to reduce the complexity and, let's say, the amount of underground stormwater pipes in the foundation. That definitely can be a huge advantage if such a system is implemented in early stages of a design. So that is definitely a nice feature of a siphonic system. If we look from a little more practical perspective, now here we see similar layouts, above again the conventional, below the siphonic. What we need in the conventional, since it's a gravitation system, or well, in fact, to be honest, both are gravitation systems. We need the gravity in both of the systems, but in the conventional, we need a fall or a slope to be installed to drain off the water in a pipe which has a filling ratio of air and water. In siphonic, we can go without slope. Like horizontally, we don't need the slope because of the negative pressure. So this gives us also a freedom of planning when we can collect large surfaces on one collector. Let's say also if we think about collecting or harvesting rainwater and direct it to a filtration station, we have more opportunities with the siphonic system. And I think indirectly also people will talk about some indirect benefits if you plan a LEED project, for example, because it can indirectly contribute to reuse grey water. From a material perspective, definitely, if we imagine the number of outlets, we can reduce the number, we can reduce the diameters, and theoretically also we can reduce the total number of pipes. So in the end, a saving of material can be possible. Obviously, it depends always on the project characteristics, the layout, the shape, the roof, and so on. So as a brief summary, if we compare a conventional to a siphonic system, the number of outlets, the diameter of the pipes, the filling ratio, the slope, which is needed for collectors, the number of stacks, the complexity of the underground pipes, I would say these are the main differences between the two systems. In addition, a siphonic system, we will see a little bit more later on, has a so-called self-cleaning effect due to the high speed which will occur in the system, and we will see a little bit more afterwards. So yeah, how does a siphonic rainwater drainage system work? The functional principle of the system, I mean, it's about physics, but in short, let's say the total energy available in a siphonic system is equal to the potential energy. Potential energy means it's resulting of the difference of heights. If we think, imagine if we see here the bucket or the water here in the bucket, if we look at one single droplet of water, it has a potential energy from top to the bottom due to the difference of height, and mainly the height difference here, or that potential energy from this elevation difference, is the motor of every siphonic system. And I mean, you can try this at home. Take a bucket, take a hose, put it exactly like here. You need to give it a little bit a starting effect by sucking, and then it will be an automatic emptying of the bucket. So basically here it's no motor, no pump, nothing needed. It's a physical principle, and of course a good design behind to achieve a negative pressure within the pipe system. Let's say here, well, we mentioned the height difference from the outlet. Let's say here from top to the point of transition where a siphonic system then transfers to the conventional, definitely is the motor. So here, for example, if we have a difference of 10 meters, this gives about 1 bar, let's say, in pressure, in negative pressure, and this is like the term as the motor of a siphonic system. Now let's wrap this quickly up with an explanatory video about the system.
Geberit Pluvia, siphonic roof drainage. Drainage made easier with negative pressure. It's the principle you need for roof drainage, because roof drainage is important. This is how siphonic roof drainage works with Geberit Pluvia. Smaller pipe diameters, which fill completely in the event of heavy rain, result in a closed water column. The water is then suctioned off the roof with negative pressure. Geberit Pluvia roof outlets make sure that all the rainwater drains off without interruption of the suction effect. And that's not all. The high flow velocity ensures that the system is self-cleaning. This cuts down on cleaning and maintenance costs. In conventional roof drainage systems, the pipes require a slope. This takes up valuable space. That isn't the case with Geberit Pluvia. With this system, no slopes are created during installation. This ensures more efficient use of space. Conventional drainage systems require several roof outlets and discharge stacks, plus a complex network of underground pipes. The Geberit Pluvia system, however, requires far fewer roof outlets, and it has smaller pipe dimensions, fewer pipes, fewer discharge stacks, and fewer connections to the sewage system. This offers flexibility for architectural designs, conserves material, and cuts down on work. The Geberit Pluvia system is suitable for almost any roof shape and offers clear advantages, including the architectural freedom it provides when it comes to planning large-scale buildings and roofs. For some roofs, siphonic roof drainage is the only solution. And that's where Geberit comes in. Take advantage of Geberit's personal project service during planning and implementation. Geberit can provide training on the building site if required and is there to help you overcome any challenge. Let it rain. Geberit Pluvia, superior roof drainage.
So there was an interesting movie which explained, or it's wrapped up the introduction, comparing the two systems and showing or highlighting the characteristics of a siphonic roof drainage system. So the outlets, they are specially designed. So here it's clearly a difference to a conventional outlet. Then what we also can see, we have this horizontal section. It comes with the fixation system with the rail support. We'll hear more about that. And then we have a downpipe, and then at some point we change again into conventional. This can be done in several locations or in several types, horizontally, vertically, inside the building, outside the building. Important is that we reduce the speed of the siphonic system to below 3 meters per second, let's say, to enter a manhole. That's quite important. And then if if we do that transition within the manhole, it must be vented. But from Geberit, definitely then when it comes to these technical details, we always discuss and then plan according to the needs of the project, the appropriate transition. So furthermore, if we see now the part load conditions, again, you can see we have a small layer of water on the roof which flows towards the outlet. Then the system more or less works like a conventional system. And maybe here the question would be, yeah, but if there is no slope, will the water really drain away? Yes, it will, even if there is no slope. I mean, we have a difference of height and an open communication, let's say an open system, and water will always find its way from top to down because of gravity. But definitely what we want to achieve is a more full scenario. And then as of, let's say, 60% air and water, the system will start to operate as a siphonic. This definitely always just depends on the rainfall intensity. So we design a system, we consider a rainfall intensity, let's say 100 millimeters per hour, and everything what is below the 100 millimeters will be what we call under part load conditions. And a siphonic system, or let's say every rainwater system, basically runs maybe 90% of its time under part load conditions. And only when we reach a certain, or when we come closer to the designed rainfall intensity, then we also will reach this a higher filling ratio. In the case of a part load, also the siphonic effect will, let's say, start off. Water column will be built on in the system, then it will be full, it will give the suction effect, and this is like an on and off motion of the siphonic effect. Once we are having the, well, let's say 100% water flow. Of course, every section of the system is designed, and every section can have a different filling ratio. So theoretically, we always talk about 100% filling ratio, but in fact, every section of a system will have a different filling ratio, and also we will never achieve, let's say, 100% everywhere. This is, let's say, what we talk theoretically to have full load conditions, but in reality, it's mostly on part load conditions. What we say, then it will be an on-off. If we have the capacity as per design for a certain time period of time, then of course then the system will run as per 100% design. We have another short video to look at this. It's from one of our hydraulic towers, where we can see a live installation with transparent pipes, and we just have a quick look into this as well. So here we see the roof outlet. Water starts to fill up, close to conventional. Then at a certain point, pipe is fully filled, and this is when siphonic starts. When it drops, gets down, then gradually also the filling ratio will get down, the speed will lower, and the effect will shut off. So it's basically always some kind of on and off effect. Of course, what we want to achieve is several times the 100% state, also because of the self-cleaning effect, and so on. The elements of a siphonic system, here, what is, I would say, the key is that all these elements must be compatible with each other. And here we're talking about the roof outlets, the pipes and the fittings, the fastening system, and the entire design. So all these four elements together will give us the system as such, so a complete system. And it's really important that we have here a compatibility between these parts. So if we look one by one, first of all, the roof outlets, what we see is on this sectional drawing that a siphonic outlet comes with a function disc. So this function disc here on the right side, you can see a schematic section as well. Here, that small line represents that function disc. So that function disc is the key because it prevents the air to get sucked into the pipework, and this only then will allow the negative pressure effect to begin. And from a capacity point of view, or let's say let's start with the capacity point of view, there are, let's say, the most commonly used outlets which have a capacity maximum 12 liters per second or 25 liters per second. There are other outlets as well available which go then up to 100 liters per second. But these large outlets are used in special cases. If we have a special roof shape design where a very large roof area comes to one point, centralized point, where we want to drain a huge amount of water. But let's say in most projects or common practice is to use 12 or 25 liter outlets. As well, from the sealing perspective, there is a wide range on the market. We have flanges, we have outlets for bitumen foils, for PVC foils, for metal gutters, for welding with flange, and so on. There's really a huge assortment necessary to cover all the different type of roofs or gutters, and so on. But the key point here is the function disc, which is needed to really, let's say, close that that connection between the atmosphere and the pipework. Pipes and fittings, there are several systems on the market with different materials, from cast iron, steel, but as you may know also already from the first webinar, the material, what Geberit believes in is high density polyethylene, HDPE, and it has, the material itself has several advantages. It is a fusion welding and electrofusion or butt welding, so this means we can really achieve a leak-proof system, and this is what we want to have as a connection when we talk about siphonic, where we have negative pressure and fulfilling within the pipes. There really we want to have something which is welded and really leak-proof. It's lightweight and easy. I would say this is another nice advantage. And when we talk about think about the installation process, HDP can be prefabricated. This is a big advantage. So a contractor can pre-weld and pre-fit certain parts of the system and then just lift it onto the roof and fix it with an easy-going fastening system. It's very easy and time saving. Other than that, there are more characteristics which makes HDP basically the best suitable material when it comes to drainage. The fastening system, what we can see here on the illustration, the siphonic system comes with a complete design solution, and it mainly consists of support rails, pipe brackets, and we could call it a rigid installation. So meaning the forces which occur due to the change of temperature. So these forces, for example, they are transmitted over the rail then to the building structure, and we do not have expansion joints horizontally. It's very simple. So we can see it here from the illustration. Also, the rail has an advantage that it's quickly installed. So we can imagine here a section of, let's say, 5 meters can be pre-assembled on the ground already with the brackets, with the rails, and then every 2.5 meters where we have a suspension to the structure, we can lift that rail into the brackets and with the tension wedge quickly fix it, and that's really a quick installation. So we have fewer sealing fastening points compared to a conventional system. I mentioned 2.5 meters. If we would have a rigid installation or even a conventional installation with expansion sockets, we would have more, well, depending on the diameter, obviously, but we would have more sealing fastening points. I mentioned the horizontal expansion, which is taken care of with the rail. Prefabrication I mentioned. So a complete system. If we look at it from a sectional perspective, we can see here again, so every 2.5 meters we need a fixation to the structure. Definitely this can be done also in different ways to steel structure, concrete, whatever. Just need to adapt here the method how to connect. Then we have these clamps which then fix the rail and the pipe brackets, where also we know that we have what we see here, rigid points and gliding points. So we manage the forces with an application technique which basically says where needs to be a rigid point, where is a gliding point. The conventional pipework uses expansion joints. This is what we know from the in-house drainage as well, where we have the fixed point, where we have an expansion socket, and then basically the pipe will then move here into the expansion joint. If you look also the diameter of the rods and the number of rods, it will be more compared to the fastening system, because here the diameter of the fixation also is in relation to the suspension or to the distance from the wall, basically the suspension from the ceiling. Sorry, if we see the fixing of the system, then when we go vertical, here we use the expansion joint, so only in the horizontal we make use of the rail, because imagine a siphonic system, we can have collectors up to 100 meters. We run them horizontally suspended with the rail under the ceiling, and then there will be few downpipes where we go to the wall or to a pillar or whatever, where we then use conventional fixation with expansion joints. Last point of the elements mentioned is the design. Definitely what is required here is roof layout and all other relevant layouts to enable to design a roof drainage system. Then isometric views will be created, and obviously with dedicated softwares, the siphonic system will be calculated. Nowadays also, for example, Geberit has a BIM plugin to design and calculate the siphonic systems, which is a service. And then out of the software, you get full material lists, including the whole fixing, tender documentation, including costing. So this is, let's say, if the design work based on 2D CAD or Revit is done, then it will be transferred into the design or calculation software, where then the software is doing the hydraulic calculation. This leads us to the point of design, how to design a siphonic rainwater drainage, the last chapter. And we have a quick overview. Basically, there are six, or we can name 6 essential steps for that process. Number 1 is the calculation of the roof area. Then we need to determine the rainfall intensity, very crucial. Number 3, out of this we can define the volumetric flow per roof area, position and define the number of outlets, and define then the pipe routing, and from there we put it into the software and design a schematic, drawing, and the whole calculation. So what is needed? I mentioned it: roof plan, a layout, a sectional drawing, core positions, where to locate downpipes, the roof type, the ceiling type, if any no-go zones within the building, and areas which might cause obstruction to the pipework. If this information is provided, that this will then probably reduce likely any redesign work being required later on in the process. So number 1, very simple, calculation of the roof area. So we take always the horizontal of any different type of roof shape. Here we see 2 examples. I think that's very clear. For the rainfall intensity, this is could be a discussion for itself. What we see here is a snapshot on the below left from, for example, Saudi Aramco engineering standard, which some rainfall intensities are given, or even a note about the intensity is given. Or on the right side, we see a graph or several graphs from an excerpt of Dubai municipality, where basically we can see here different graphs per return period from 2, 5, 10, 25, 50 to 100 years. So this is a simulation model, and we see the intensity in millimeters per hour and over the duration of the event. So what we can see here easily is that in the first 20 minutes, usually a rainfall has the highest intensity, and the longer a rain for this region then occurs, it will reduce the intensity. So what we always say from Geberit is that this value must be determined together with the architect and mainly the MEP consultant, and in Europe even possibly with the building insurer. And this value should be based on statistics from meteorological institutes. What we always recommend is to consider the 10 minutes within 10 years rainfall intensity. But definitely, I mean, it doesn't matter between siphonic or conventional. This I would like to add here. You can design a rainwater system, consider any kind of intensity, and your system will deliver what you design. This is just what needs to be known. And then as well, number 2 here is to talk or think about the emergency, let's say the case where, or let's, as I mentioned before, the term primary system, where we design a primary system with the rainfall intensity, but then we need to consider the case if the intensity we have chosen before will be higher over a significant time. So where is my rainwater going to? If it will rain more than I designed, will there be a stagnation on the roof? Will it flow into the building? Will it overflow or whatever? So the emergency is quite crucial. From Geberit, we follow DIN standard 1986, where basically we recommend to consider a 5-minute rainfall intensity from the 100-year storm. So then the minimum discharge capacity of the emergency overflow results from the difference between the 5-minute rainfall and the maximum discharge capacity of the roof drainage system. This basically here, this equation shows the R stands for the rainfall intensity, so the 5 minutes 100 year minus what has been defined. We would recommend the 10-minute 10 years intensity, so this difference should be provided by an emergency system at least. So this is our recommendation, really, that every roof drainage system theoretically can fail, and so we need really to think about also an emergency case. And this is really apart from the discussion about siphonic. It's the same case for a conventional system. So here, I just briefly would mention a few options. We can oversize the system in general. We can provide as a secondary siphonic system with adapted outlets. So it means we have a primary system, we have an emergency system, which are both working independently from each other. We can provide an internal gravity overflow system next to a siphonic system as well, or we can provide weir overflows, conventional overflows through the parapet walls, etc. Or even we can allow the potential excess temporarily on the roof to build up and then to drain away. So there is several options. Just really crucial that in design stage, this is a topic on the agenda, and the right solution is found and designed. Definitely, we can help and recommend what to do. Then number 3 is to define the volumetric flow. So it's the surface times the intensity and with the capacity factor for the roof. So here's a small example: 1,000 square meter, intensity of 0.03 liters per second in square meter with a capacity factor of 1 is then 30 liters we need to drain. And the number of outlets is quite simple. So we just take the amount of liters we want to drain divided by the initial or the maximum capacity of the outlet. So in this case, we would, let's say, take a 12 liters per second outlet, will result in 2.5. So we round it up to the next figure, which then will result in 3 outlets. Then also there are some rules like minimum distances between outlets, which is 20 meters. We should not extend between 2 outlets, and also the minimum distance and maximum distance to an edge of a roof. So then we can start to plan and divide the outlets. And once we have done this, then the pipe layout can be designed, of course, in coordination with the project. But again, here we see a little bit the traditional, or let's say the most suitable design. It's an outlet, a small downpipe, then a horizontal pipe section which finds a horizontal collector. So this is a typical siphonic roof layout, and then we have the downpipe in the same time. So if this design has been implemented into the roof layout and other layouts, then we go into the dedicated software where we can replicate the design in an isometric view, and basically every outlet then has his defined capacity, and we can then let this, the software design the pipe layout, and then there can be some iterations, optimizations done individually by the designers by adjusting some diameters. But really important to know, every significant change in a design needs to be recalculated in the Siphonic system. So as a summary, we're already at the end of the content. As a summary, we can say that, number one, a siphonic rainwater drainage works differently to conventional, definitely with the siphonic effect, with the negative pressure, which is operating within the full pipe work once we have the effect is starting. We have definitely more freedom in design because of the horizontal large collectors we can do. I mentioned that we can go even up to 100 meters. Theoretically, even more would be possible. Environmentally, it's more friendly because of the reduction of the material. It's pretty fast in installation, and we have a self-cleaning effect. It's a complete system. So this we have seen on the outlets, pipes, brackets, fittings, software service. So also the system comes with a warranty of 10 years with Geberit. That's definitely also very nice. So we use fewer outlets as well, less pipe works due to the filling ratio and the initial capacity of the outlets. It needs careful design, yes, and it needs to be really implemented in the design process. But here, the service from manufacturers must be there. From Geberit, I can assure you that we have these dedicated design teams, designers which are taking care of siphonic designs, plus on-site supervision and support must be there to have, or even to issue a 10 years warranty. Siphonic is a well-established principle. We have over 40 years of experience within Geberit, so this is not something new, it's really something established. There are many projects installed with Siphonic systems on the globe. So basically this would be the end of today's presentation, and I suggest we are going into the question and answering session.
Thank you, Remo, for that presentation. It was quite insightful once again. At this point, as Remo mentioned, we will move to the Q&A session, which will be limited to 15 minutes. Please submit your questions regarding today's presentation on the Q&A bar on the right side if you haven't already, and Remo will answer them. So one of the questions is, what about overflow outlets?
Yeah, overflow outlets definitely are required, no matter what system is planned, conventional or siphonic. We need to think about overflow outlets. There is though different possibilities. We can have a conventional overflow system, meaning a conventional one with gravity. We can have a siphonic overflow system, so meaning there are emergency overflow outlets which are siphonic. The difference is they come with a small additional piece inside which prevents the water to get into the outlets after a damming height of 55 millimeters. So basically the overflow outlets must start working as of a damming height of 55 millimeters. Or even there can be architectural solutions with openings into the facade, let's say emergency alerts. So there are basically different options how to use or how to implement overflow outlets.
We've also received a question from an RIBA architect. It was mentioned that the system is self-cleaning. In traditional drainage systems, implemented at sunk roofs, there is a requirement to design emergency outlets within upstand walls perimeter to roof layout. This is in case of blockage of roof inlets. Is this also a requirement if pluvia is implemented as a drainage system?
Yeah, so basically, I think there's two. One is probably the accessibility. So in a siphonic system, you don't need any additional cleaning access for the siphonic system as such. Basically, what is important is that there is maintenance carried out on the outlets itself. There will be maintenance instructions or guidance provided to the contractors or FM teams. So regularly the outlets need to be checked if there are any blockages or whatever on the roofs to let's say basically block the outlet from working. That's the biggest risk. The system then itself is self-cleaning, and if it works a few times during the year, then basically the pipe is clean inside. So there is no additional. Let's say the maintenance or cleaning is a topic as such. Then the emergency system, as mentioned before, is a separate system apart from the siphonic.
Right. Another question, is 20 meters the maximum distance between outlets?
Yes, that's definitely for Geberit the case. Maybe this may vary from different manufacturers.
We have a question from Robert here. Have standards been developed for HPDE in Gulf region? Example, UK BRE has an office, Dubai, and noted Brit standards for UPVC, not adequate due to localized environmental conditions. They noted potential longer-term liability issues for consultants.
Yeah, so standards in terms of there is no special standards developed. Definitely, we did some analysis before we introduced this system here in the region because of the climate conditions and so on. But this research basically has shown that there is not an issue not to provide siphonic systems. There are projects here in the region which come with a siphonic system. So with municipalities, these projects have been approved and discussed. I think the main topic is about the rainfall intensity and also the phenomenon of cloud seeding, what we see and observe, and then that's the point how to basically design a system. But again, this discussion is out of the is not only within the context of the siphonic roof drainage system, but definitely we refer to European standards and certificates which we are having for siphonic, from ISO certificates, BBA, BSEN 8904. So there's a lot of content, but nothing yet specific for the Gulf.
Right. What is the total spacing required from the underside of slab to the underside of siphonic pipes?
Yeah, depends, of course, what is possible. We just launched in April a new fixation feature, let's say, to prevent horizontal swinging of the system. I just missed the exact term. But yeah, let's say as of 60 centimeters suspension, or then up to 1 meter. It depends also on the diameter, on the size of the collector. We need to have a additional lateral support. And so then when we have we need to just think on this, or let's say a system will start to swing when it's suspended too much from the ceiling. But then we have a solution. with the lateral support. So then basically we can suspend it more than 1 meter.
We have a question here from Sandra. What examples of local installations are there?
Reference projects, I believe. Well, in the UAE, there is a Remo Abu Dhabi under construction, a large one, the Strata factory in Al Ain, in Qatar, FIFA football stadiums like Al Wakra, Al Tumamma, Al Rayyan. Saudi Arabia, there is a factory which is there. Oman, Salah, Muscat Airport, some buildings there. In Riyadh, the Zahadid metro station is a Siphonic project. Yeah, there's a couple of projects in the market. Probably the most famous are definitely the FIFA football stadiums for 2022, which are pretty huge.
We have a question from Tom. What maintenance, if any, is needed? What would be a typical lifetime for an HDPE system?
Yeah, good question, Tom. The maintenance, I think I mentioned it a bit in the beginning. So definitely the outlets is crucial on a regular basis to check the roof if the function disk is properly installed. And yeah, we recommend, or what we basically do is always to give an instruction after handover how to maintain the outlets. The lifetime of a HDPE system is, HDPE can last for 40, 50 years. So the warranty is 10 years. The material itself has a lifetime warranty as the building structure, I would say.
We have a question regarding what types of roof buildup can the system work with?
Yeah, all kind of roof buildups. A Siphonic system can be implemented. So therefore we have this wide range of outlets. Then yeah, basically the key is the type of ceiling. And then we need to choose the adequate outlet. But maybe the size of the roof can be mentioned. So we usually say as of 1,000 square meters roof size, it starts to be interesting. Of course, the larger the surface, I would say, the more interesting a Siphonic solution will become. But particularly on the, let's say, technical structural build-up, there is no limitations.
Another question we have here is that I hope the system does not produce the noise in the video. I take it that was the sound of the pumps filling the demonstration tank.
Yeah, exactly. That was that noise is quite a strong one. So definitely this was the pumps we could hear. Nevertheless, we need to be honest and really say that the Siphonic system can have some noise. Definitely it's a system not for a high quality residential area or for a luxury hotel, basically where we have the pipe running through sensible areas of a building. Definitely that it shouldn't be recommended. It is a system which is largely used for industrial buildings, public buildings, malls, commercial, or stadiums, airports. Let's say this category or this segment of projects. So we would not recommend to use the system in a acoustically very sensible environment. That's true, but it will not be as loud as it was in the video.
We have a question here regarding whether you might have any data on the cost benefits.
Yeah, definitely we did, of course, already a lot of studies for projects. But if there would be an interest approach Geberit and ask for the project service, so we can work out really, that's always the best, to work out a project specific offer. This is all free of charge without any commitment. We are happy to offer the service to look into any kind of project and see if there are really opportunities, also of course then from the cost perspective. And I think always that's the best point is if together with the client then we can look into it when we provide on our hand our cost, and on the same time that they can compare what they're having on the table.
A delegate has asked, what about overflow systems?
Can you say it again, please?
What about overflow systems?
What about, yeah, I think this is similar like in the beginning. What about overflows? Yeah, it's very important. We need to have it on every building. We should have it on every building. If we imagine here Dubai, I mean, what we have seen January, last November, there was a tweet by media office. We have seen intensities of 150 millimeters per hour. So if your system is designed for, let's say, 75 millimeters, there is a result of a difference of 75 additional millimeters per hour of rain which is coming, and usually the peak time, like the intensity, will be in the. That's what we have seen. I mean, we have seen that is in the first minutes, where then yeah, the flooding could happen, or in the worst case, even the structure can collapse when we have a buildup of damming height. So we need to look into overflows. As mentioned, there are several different options possible. Siphonic can be one of the options, definitely, but it's not the only one. But I think in general, we need to have a solution in mind. What is with that excess water? Where does it go? And how much can my primary system really drain? I think that is the, let's say, the initial key discussion about that topic.
We have a question here regarding what is the coverage area per outlet?
Yeah, the coverage area per outlet depends. So we have when we start calculation with liters per second per outlet, then we need to know, okay, which intensity we are using. Then we can from there we can derive the area, but also it depends on the architectural layout. So we need to see, depending on the architectural layout, that really the water then also can flow towards the outlet. So maybe then I need to consider several outlets maybe for a smaller area than the outlet really could take. And we have different type of outlets as well, like 12 or 25 liters. But let's say if we take a 25 liters per second outlet and 0.03 liters, or like around 100 millimeters per hour, then we come around, let's say, 800 square meters. But then, depending on the layout, we need to see what is possible.
We have a question regarding how will this drainage system perform with sand getting into the drain in addition to water and air? Yeah, this is of course a topic here in the region. When I mentioned in the beginning that we have done analysis, then it was exactly about that topic. But sand basically is not an issue. I mean, otherwise also a conventional system would have a problem with sand. On the other hand, the cleaning, self-cleaning effect just will wash away small particles of sand. And sometimes people think that sand will really accumulate around the outlet, or then even stock the first bend, which is below the outlet. This was a bit maybe the main feedback out of several discussions. But just in fact, this is not happening. If water is flowing over the sand, which would be around the outlet, it needs really
much water with quite a high speed to carry the sand in significant volume into the drainage pipe, and this is not happening. It's just like always taking a little bit sand from the surface, and then we talk about the mixture of sand and water where much more water is drained away and the sand is like neglectable. Yeah.
And this will be our last question for today's session. Actually, we have a question from Mark. Can we get the software to design our own systems?
So what we do in Geberit, we have a policy on the software. So we don't just provide the software to anybody because we give a 10 years warranty. So Geberit needs to understand the design. So we don't just provide that software. This is a design service from Geberit. Sometimes in certain markets, if this is included in the market plan, we do train external people. So then we have a 1-week training in our headquarters about the system and also about the software, which is a prerequisite then to obtain a software license. Sometimes, yes, we do that, but usually in the Gulf, it's Geberit which is working on the software.
Well, thank you very much for that seminar, Remo. That was very interesting to learn about. Apologies, everyone, and Remo for the technical issues this session.
Sorry again.
I would like to thank our audience spanning across 7 countries in the Gulf for joining us today. The RIBA with Geberit will be hosting more modules of the series in the near future, and we hope you will join us for them. Thank you once again, Luis and Remo, for the wonderful presentation, and I would like to thank Geberit once more for their kind support in sponsoring the series. Thank you, everyone. We hope to see you at our future events. Thank you.
Thank you very much.